So good morning, everybody, and welcome to the University of Bremen and Bremen to the iJOIN Winter School. A warm welcome here from my side, and I'm very interesting to see what's coming out of the next 2 days on the winter school. You see, the title is quite interesting, I guess, and it's very interesting to see that especially iJOIN organizes that winter school, and I'm happy to see also during the next 2 days a lot of people, not only from iJOIN, from other projects here showing up and discussing here 5G cloud technologies, the benefits and the challenges. So you have the 2 days, and I once again like to welcome you here at the University of Bremen, and we are pleased to give you this opportunity here to have the workshop here, or this iJOIN Winter School here in our university. So let me just quickly introduce in 10 minutes a little bit where you are and what kind of university we are, especially also give you a little bit an insight of our department, what we are doing. Most of you mainly know because we are also deeply involved in the iJOIN project, especially on the distributed concepts, but nevertheless give me just a chance to introduce a little bit my department here at the university. So that's the Department of Communication Engineering, it's called, and it's a quite large group meanwhile, and we are active in many projects. But before, let me give you a quick overview what kind of university is the University of Bremen. First of all, it's a pretty new university. We were founded in the 1971 here, and we are quite let me say, successful in the DFG funding and funding in general. You see here, for example, we are here as a top 2 ranked university in Germany regarding third-party funding. And we are very proud that 2 years ago we won one of these initiatives of the DFG. The DFG is the German Research Foundation, and we are called an Excellence University. So we are, I guess, one of the 12 Excellence University in Germany, and this is something where we are very proud of because, once again, we are just here quite young university, and we are a mid-size university. That means we have roughly 20,000 students, so we are called a mid-size university, and we have 3,500 employees here at the university in total. You see here there are especially a lot of bachelor studies, and we also meanwhile offer here master studies, international master studies, especially for example in communication engineering. We have an international master study here set up a few years ago, and we can offer roughly 70 places here for students. We have applications of around 700. So you see it's much overloaded here, this kind of applications for the master study, but nevertheless, I guess it has to be due because the Excellence University is a branding market here which is already visible in all over the world. So especially this is the campus of the university here, that's the center of the university, and you are located here. The building here is for the physics and for the electrical engineering studies here. So we have this kind of joint faculty between physics and electrical engineering. So you are here exactly in this building. Sorry for that. Okay. So the organizing team here is my department here. We are called Department of Communication Engineering. In Germany, it's Arbeitsbereich Nachrichtentechnik. That's where this "and" comes from. So we are exactly working like ants here. So but we belong to the Institute of Telecommunication and High Frequency Technologies, and this institute is Professor Schneider. He is doing more the RF side, so the radio frequency engineering, the antenna design, etc. While on the other hand side here we have the protocol guys here from the Institute Comnets here, the Professor Görg and Professor Anna Förster here. Professor Anna Förster joined the university just a few weeks ago here, and we are right in the middle here. That's the Department of Communication Engineering. So what are we doing? When you just let me say, have a very abstract overview on what are our research branches, I guess it's quite obvious that what most of you guys know, my department here is in the 5G area here, especially regarding the iJOIN concepts like the small cell deployment, like the backhaul issues, and the cloud RAN technologies in combination. So that's 5G, but we have another 5G topic here, which is the massive machine type communication. Some of you know that we are part of the project METIS. And in METIS, we push heavily the machine type communication scenarios here, especially dealing the random access, means to go for direct random access with massive machine type communication support, and we do that by some new physical layer technologies. So this is the part we're doing in the 5G environment, but meanwhile we set up in the last 2 years some other research branches which is called Industry 4.0. In Industry 4.0, that's the way where we like to go to machines. Means we combine wireless technologies with automation production in order to improve the whole production process, for example, like shown here. So there will be many sensors here, and they have to let me say, transmit control information for a control loop of an automation process here. Therefore, we are strongly required with challenges like very low latency, very high reliability, as well as, for example, also to support a massive communication scenario with many sensors implemented here in such a production process here. As well as, for example, to control this process here by an iPad, whatever, which runtimes requires also very low latencies as well as small packets to be transmitted. And there's another third research branch we are doing a little bit in my department. It's called the medical recording. The medical recording means we are measuring neuronal signals in the brain and transmit these neuronal signals to the outside in order to give the medical guys the idea what's going on in your brain. Right? This is somehow strongly related to low latency, very high reliability, as well as security issues are showing up here heavily. But that's exactly what we're doing here. So we measure here the neuronal signals in the brain and transmit that, for example, here to the outside, where it can be further processed by some external devices, etc. So these are the main research branches we are doing in my department here. You see roughly a quick overview of the project as well as where we're active here. You see on the left-hand side, we are heavily in the really, let me say, fundamental research area funded mainly by the German Research Foundation. That's where we really try to understand theory, try to come up with new ideas, mainly based on theoretical results. But then we make the results more mature and transfer it to projects like the iJOIN project, like the METIS project, and meanwhile also in the Industry 4.0, the projects HyFlex and the BZKI project. And you see we have here partners which are not typical wireless companies. These partners are more coming from automation. Means, for example, Phoenix Contact, they are doing some wireless communication, but they are really specific experts in automation, right? So this is exactly where we have some BFG branded project, as well as then finally here with the direct industrial cooperation, Alcatel-Lucent here, for example, one of my former employees here, as well as Docomo, we have collaboration ongoing. And you see on the right hand side, these are the forums and the respective organizations we are members of here, like the NetWorld, the 5G PPP, One M2M Forum, especially to push the massive machine type communication forward, as well as the ETSI here, for example, in order to handle spectrum regulation issues regarding automation industry compared to the wireless industry, because there's a strong fight between the automation guys and the wireless guys in order to get the right spectrum. So this is exactly where we are active here in this kind of, let me say, research for us. So you see we cover mainly from fundamental research up to, let me say, the transfer to the industry in order to make the technologies more mature here. And finally, the last slide, the research in a nutshell. So the organization of the department is as follows. We have mainly 3 senior researchers here. Dirk Rüben, exactly most of you already know here because he is active in iJOIN quite heavily, and the Work Package 2 leader here, and he also organized here the workshop here together with Henning. Henning here is the 2nd senior researcher here. And then we have a 3rd one, Carsten Bockelmann, and you see Dirk is mainly responsible for the cooperative communication, where we covered buzzwords like network coding, two-way relaying, waveform designs, millimeter wave technologies, etc. And then we have Henning here. He is in charge of pushing forward the in-network processing research activities here. That's exactly also one of the topics we are doing in iJOIN here, like to distribute the linear estimation as well as meanwhile the nonlinear estimation. We have some fundamental research ongoing there. And then finally we have also the compressed sensing here, where Carsten Bockelmann is in charge of. That's exactly where we push forward the massive machine type communication in sense of what we call the compressive sensing multi-user detection principles. Means we try to avoid a lot of signaling overhead when a sensor needs to signal that he likes to transmit something. So all these access reservation protocols should be avoided, and that's why we apply here something which is called compressed sensing multi-user detection, because that's a technology which helps us really to get rid of this activity protocol stuff here before the transmission is ongoing. And that's exactly also the technology where we try to get the problem handled of the medical recording here, like the compressive sampling and signal acquisition, because in order to get neuronal signals here you have to apply new signal processing concepts. That's what we do here in the research branch of the compressed sensing. So this is roughly in total. And finally, one slide, we are not only doing some, let me say, theoretical research here, we also have some hardware platform meanwhile set up here, which is a so-called NuTech platform. It allows us to do some offline processing on MATLAB, do some VDH synthesis, bring it to an FPGA DSP platform, transmit the signals, and do the other thing exactly vice versa on the receiving side here. And meanwhile we have set up here mainly the LTE physical layer transmission between the transceivers here, and that's exactly why we are doing that. We try to do some over-air testing of the PHY and MAC technologies we are, let me say, working out on a research level on papers, but then already get some ideas how practical implementations make the problems much more severe, and try to get some algorithms more handled when you really have to include practical aspects. So we have this kind of hardware platform. We are more or less extending this hardware platform to a multi-hop relaying concept. It means we have here some relays, some sensors maybe here in between. So but meanwhile we have exactly this kind of platform in the lab, and we also bring that platform to the, let me say, teaching concepts, because we also have to do some laboratory works with students on that platforms. So this ends up my quick welcome, and once again I'm really happy to organize here the conference or the workshop here of the iJOIN Winter School here, and I wish 2 days of very interesting discussions, very interesting talks. I guess the agenda is quite crowded, and therefore I do not like to spend more time on introducing my department. Thank you very much for your attention, and once again have fun for the next 2 days. Thanks.